In this lesson, I'll show you how to use the product rule to find the derivative of a function. This is part 2. The question reads, find the derivative of y is equal to bracket x squared plus 2 bracket x minus 5. And I've given this question an easy difficulty level, and I'll explain to you why after I show you how to do it. What you have to do to apply the product rule is define your two factors, and we'll use u and v just to remain consistent with the definition provided. So I'll call this u, and I'll call this v. According to the definition, we have to keep u the way it is and find the derivative of v. Then we will keep v the way it is and find the derivative of u. Let's go ahead and do that. Y prime, which represents the derivative, u the way it is, x squared plus 2, and the derivative of v, well, we can use the power rule for that. If we find the derivative of v, we end up with the derivative of x is 1, and the derivative of any constant is 0. So we can put a 0 there, or we can just leave it. I'll take this one and multiply it by u. Now, I'll keep v the way it is, so plus x minus 5, and find the derivative of u. So u prime is, we can use the power rule for x to the power of 2. That becomes 2x. And if you're not familiar with the power rule, I do have a lesson on that, so you can review that. Plus the derivative of 2, which is 0. So I'm going to multiply this expression by 2x. Now all I have to do is clean this up. I already found the derivative, x squared plus 2, and I'll multiply this 2x to these two terms. So I end up with 2x squared minus 10x. Collecting like terms, this term and this term are alike, leaving us with 3x squared minus 10x plus 2. Now I refer to this question as being easy. The reason why is because we could have multiplied the two factors together from the start and taken the derivative term by term using the power rule. For instance, I could have multiplied all of this out, expanded this, and then individually found their derivatives. Let's move on to question 2. Question 2 has a medium level difficulty because you can't use that little trick. You can't multiply x to these two terms because we have a radical symbol here. Let's rewrite this function, x plus 5, and we want to rewrite it without radicals. It makes more sense that way. So we have x minus 3 to the power of half. Mathematically, this expression and this expression mean the exact same thing. We will define this as u and this as v, and I'm going to go ahead and find the derivative of u and then the derivative of v, and then apply the product rule. The derivative of u is easy, it's simply 1. The derivative of v, well, that's where it gets a little complicated because we have to apply the chain rule. We'll take this 1 over 2 and write it at the bottom, multiply that by the base, x minus 3 to the power of 1 over 2 minus 1, and we find the derivative of this, x minus 3, is simply 1. So the derivative of v is 1 over 2, and half minus 1 is negative half. So x minus 3 to the power of negative half, and this can be rewritten, if you like, as 1 over 2 times the square root of x minus 3. I found the derivative of u and the derivative of v. Let's go ahead and apply the product rule. Leave u the way it is, x plus 5, and multiply it by the derivative of v, which is right here. If I multiply this by this, I end up with x plus 5 over 2, the square root of x minus 3, plus, now we keep this part the way it is, x minus 3, and I don't need to write it as half anymore, I can write it as radical, so the square root of x minus 3, times the derivative of u, that part is easy, it's multiplied by 1, and this is the derivative of our function. Now, of course, you can combine these two terms together It's really not hard to do. You find a common denominator. If your teacher doesn't expect that, then simply write this out and you'll be fine. And so there you have it. 2 examples on how to use the product rule to find the derivative.